Our next talk is by Tom Grubb, From Planning to Testing in Hardware I&T with the Mixed Reality Exploration Toolkit, aka MERIT. Tom is there we go, now I can see, 35-year NASA civil servant and the AR/VR product development lead for the NASA GSFC AR/VR Research and Development Lab. They're developing multiple AR and VR prototypes and projects in support of science and engineering, including the Roman Space Telescope, Mars Sample Return, and the on-orbit servicing, assembly, and manufacturing missions. He's the project lead for MERIT, which is a NASA open source tool for rapidly building XR environments for NASA domain projects. He's the PI on the Earth Science Technology Office project GEOS Visualization and Lagrangian Dynamics Immersive Extended Reality Tool for Scientific Discovery. Say that one 5 times fast. They seek to visualize climate model data in XR. Tom, over to you.
All right, can you hear me? Is it on? Yep, okay, thank you. Good job getting all the acronyms and saying them right. Welcome. She already told you the title. This is kind of the agenda. I'll give you some background, talk briefly about MERIT and how we are using and want to use MERIT for hardware integration and test. She already said this, so I'm going to skip this, but I've been at NASA for quite a while at this point. We started, like a lot of these XR groups, in 2016, once the Oculus Rift became a thing, or the DK2 or whatever it's called, and we started with internal research and development funding, some NASA headquarters funding, and then some organizational fundings. And what I didn't appreciate at the time is I was told to go and talk to everyone across the center, the scientists and engineers, and get a survey and come up with ideas about how to use XR to benefit NASA and our scientists and engineers. And we came up with 16 ideas, presented the best 6, and got funded for five of them. And then we work with multiple missions, scientists and engineers, and lots of universities, and APL. So I'm sure you've seen this about the mixed reality spectrum. On the right, you have, everything's generated by the computer. It's a digital world, and you slowly start blending between the real and the physical as you go to the left, and you use different devices. The reason I bring that up is that how does this apply to use cases in hardware I&T, at least in the NASA context? So on the right, you have everything in the digital world, and you don't have access to the satellite. It hasn't been built yet. You don't have access to the chambers, the thermal vac chambers, or anything else. So everything is going to be in VR, and what can you do? You can do planning for your hardware integration and test. You can do fit checks. Can you get your body in there? Can you get tools in there? How you're going to hook up the harness routing between your test equipment and the satellites or instruments. And of course, training, walkthroughs, et cetera. And then as you slowly go and mature the project, you start getting access to real hardware, real chambers, and you start going into augmented reality. And at the end there, you do the actual integration and test. You want to have live telemetry from your test equipment or from the instrument itself, and you can do documentation over in QA. So in general, we kind of took that and said, okay, what are the type of features do we need for supporting these type of scenarios? There's general stuff. You want to pull in the models. You want to place them, move them, collaboration, notes, load, save projects, et cetera. For the fit checks and reach and access, obviously collision detection, track the head, the hands, and then eventually the full body, measurements, et cetera. Planning and training, we want to record what you do and be able to play it back because you want to plan it and then show it in AR. And you want to be able to do things like documentation, take pictures of what you've planned, or video. For harness routing, laying down the cables, obviously you need to be able to lay the cables down, specify things like width, the width of the cable, length. You may want physics-based cabling. What's the bend ability of the cable, or letting it drape based upon gravity, things like that. And plugs and connectors. And then the IT, you want checklists. You have to have access to the telemetry sources. You probably want area, object, and image recognition to say, okay, I'm looking at this piece of hardware, show me that telemetry, and voice recognition. That's not intended to be complete. I'm just showing you this. This is something that Lockheed Martin did a few years back now, or a couple years back, and it was just to show what their plan for the hardware INT, all the steps. And so they generated this whole video, came through these things, and it's fantastic. It tells you what's happening. It helps the hardware engineers. But you're stuck with the order they show you. You're stuck with the viewpoint they show you. So we wanted to be able to expand upon that with this tool so you can move where you need to see. You can say, no, that's not right. Let me, change the ordering or delete an ordering or anything else. So about Merit. It's cross-domain. It's designed for the entire mission life cycle in science and engineering, and to help us rapidly build XR environments for NASA-type problems. Unlike a lot of development I've seen in XR, it's like you develop for a specific scenario, and then you go to the next one, you copy over a lot of the code and data and everything else, and you then code. It's much more designed like Microsoft Word in the sense. Word is an application that loads a document, and it says, okay, this is what I need to display. And this is kind of similar to how Merit's trying to do it. We're open source, NASA open source. We're on GitHub. We integrate with NASA data. We can do secure collaboration within the VPN. And finally, we have this common feature set. And then we support VR as our bread and butter. We have a desktop mode to help for people who don't have the headsets. And then the HoloLens 2 is our AR mode. So it's a common platform for NASA XR, and these were actually the original 5 things that were funded. And we said we were recreating the wheel every time, and we were like, let's stop that. Let's make Merit so we can support all of these. So just briefly, showing you there's Merit. It reads in an XML file, reads into the objects, whatever type they are, and then displays it to the user. We can combine 3D models, point clouds, terrains. I've mentioned most of the stuff. We can drive models from the telemetry. So we could take telemetry from orbit that shows the joint angles of a robotic arm, and whether that's on ROS, the robot operating system, or in another middleware called Gemsec, we can then take that and drive our 3D models and show what's happening in orbit. And as I mentioned, it's across the life cycle. All of these are different ones we either have worked on, are currently working on, or are trying to complete. The important part about the stakeholders of Merit is that these kind of say what the features are. And the first 3 are missions. Roman Space Telescope, it's the next big telescope that NASA's going to launch. So they wanted to do things like fit checks, reaching access. Can they get in there? I'd like to talk about, there was an engineer I worked with. She was a tiny woman, and she was always chosen to do the work because she was the one that could actually get in and get to the stuff. So hopefully by using our tool, they can make it a little bit so she doesn't have to do everything. And then, OSAM-1 is an on-orbit and servicing mission. They want to do hardware INT, but we're also, as I just mentioned, talking about we can subscribe to telemetry, and we could do it as a situational awareness tool and show what's happening. And this is using simulated telemetry, move the robotic arm, seat clearance, reach, and those type of things. And then the Mars sample return, we're also working, and they want to do hardware INT as well. And we're looking at pulling in these full body type sensors. This one's from Movella. I guess it used to be Xsense. And we have an intern working on it, and that's why it's not quite correct with the tool there. And then we have a couple other customers or proposals, Planetary Science, where we are working on ConOps for Lunar South Pole, and ConOps between people pretending to be astronauts in the desert using HoloLenses, and then people back at Goddard in VR, and seeing the same terrain once scanned beforehand, and working together. I put a pin, I want you to look at this rock, take a sample of this rock, that type of stuff. That's one we're working on, and we're also working on Earth science, and this will be looking at visualizing atmospheric type phenomena from climate model. We integrate with a lot of stuff, Gemsec, MATLAB, SPICE, which is something, JPL software for saying if you're on the moon at this location at this time, where's the Earth, where's the sun, et cetera. And it could be for any planetary body. So that's obviously useful to us. ROS, which may be useful to a lot of people here, integration with the robot operating system. Rapid Model Import Tool, which is a Kennedy Space Center open source software for converting CAD models to XR-ready models, decimating them, et cetera. And then we are integrating with the NASA IoT platform, which has a little bit different, it has actual security, unlike IoT platforms generally, and it puts NASA flavor on it. I mentioned Gemsec just briefly to tell you, this is a middleware for mission operation centers. The whole point of Gemsec was to allow mission operations to rapidly build mission operation centers. It standardizes the API as well as the messages that different components in the mission operation centers could do. The point being that it's very loosely coupled. As we have 10, 30-year missions, we can swap out the different components of a mission operations center and even swap out the middleware underneath, and we can stay current. The reason it's important to me is that Gemsec is used in, it's 30 when I knew, it's probably more now, mission operation centers at Goddard, Ames, and Space Force. And it has authority to operate within the VPN. It's highly secure. Space Force paid quite a bit more money to harden it, even more. So by making Merit Gemsec compliant, one, we get that access to telemetry, but then we can also do our collaboration within the VPN. This is how we do it. We don't use a game server, which for some reason NASA security had a problem with, but we can do all this securely and in those environments, which I've already talked about. So going back to this slide, Merit is designed that we're trying to fulfill this whole range, the spectrum. And we're mostly, since we started in VR, our AR is not quite feature complete at this point. That's why kind of a dashed line there. Kind of talking about different features I mentioned earlier and how they map to what we have. Right now, the current version that was released in June, which was Merit 2022, excuse the numbering system. These are kind of the features that I mentioned before and how we're supporting them. And then as we go to our next release, which hopefully is at the end of this calendar year, and this is the open source release, we'll be adding the full body fit checks, physics cabling, hopefully better feature parity, and collaboration between VR and AR. Right now, it's all within the VR. We don't have it going out to the HoloLens, but we're going to make it so we can do that. But Any other features I didn't mention earlier? I think that's good enough. But we need that between VR and AR for that planetary science. So the other important thing is we want to make it this, okay, you work in VR, you plan everything in VR, you save your project with all the steps, and then we load that exact same project, go to the HoloLens, you're doing your actual integration and test, and you can see the same steps, you can load the same cabling, et cetera, et cetera. And then the collaboration, which I've mentioned, one of the things I didn't mention is that we also have like an on-demand sharing. So the first person loads in the project, everyone that joins that automatically gets that distributed. They don't have access to the models. And that we can't collaborate with AR yet. And then I mentioned a few times the integration with NASA data. Not only can we drive the joint angles, but we can take like red and yellow limits and show the, as things go wrong, give a situational awareness tool. And if you tie this to like an archive system, you could do it as for analysis to kind of scrub through what were the cascading series of events. Oh, this got hot first, and that caused this, and et cetera. So just in conclusion, I think everyone here would agree that XR can play a strong role across all the stages of hardware INT and across in VR and AR. I believe that Merit, as it is now and as it's going to be in the future, it can play a strong role for that as an open source tool, and it's only getting better. And something that some people may not be aware, there is a HoloLens version that's the industrial edition, which is clean room certified, which is a big deal for us. So it doesn't have to be in normal environments. We can do it in the clean room and support that. And that's it. I guess I was faster than I thought, Nick. Any questions?
I'll try and plant one for you. So just in your aspirations for Merit, where do you see it going? How broadly would you like to see it used by others, right? What is your dream?
I mean, obviously, I'd like to see it very broadly used, but realistically, I am hoping it's used in many locations across NASA and in engineering domains and in science domains. I'm taking those 5 funding sources, and I work with their stakeholders in my, we have a configuration control board, and they come to us and say, these are our requirements, this is what we need you to do. And then I balance those requirements from all of the stakeholders and go, oh, if I take your feature and just turn it slightly or add things, I can support multiple domains. And so I expect that this will only keep growing. And we will get, as open source, we'll get more contributions. UMBC contributed a network visualization tool, so like network topology, that is originally developed by the Army Research Lab for NATO cybersecurity exercises. And that's been integrated into Merit. CNES, the French Space Agency, would like to use our lunar South Pole type projects for habitat. And they're going to add features to that they need. And then we will pull those back in and then distribute them to the broader community. APL, hopefully, will adopt Merit more broadly and will contribute features back, and that we can all work together to add integration with new data sources, new features, et cetera.
Hi.
In typical fashion, services and agencies only see each other in public venues like universities, right? So it's great to learn about merit. I can say from, I guess I would call it a foxhole, my particular spot under the Army Futures Command Enterprise. I track the big picture as being the synthetic training environment. So that is a future capability that we all know about, but nobody necessarily has implemented. Although you can talk to individuals and they will tell you, absolutely, anybody could come and plug a USB into our system and we're integrated. But I'm tracking that there are, various research labs, possibly affiliated with UARCs, that are saying, we've got it. We've got it figured out. We've plugged this into that, and this into that, and this into that. We've got our layers separated. Here's our simulation. Here's our environment. Here's our various plugins or hardware. I'm wondering whether or not whether or not you feel like there's any overlap between what Army Futures Command is trying to do with the synthetic training environment. Specifically, they are talking about a common operational environment for training. I know that extends into not just training, but things such as an environment for digital twins, because if you're doing training in there, you might as well do your assessment, mechanical engineering in there too, right? There's work being done at University of Southern California for plugins that allow multiple layers of modeling and simulation. I know there's stuff being done down in Orlando. There's a hub there at University of Central Florida where Army has labs. So I'm curious whether or not this is something that you're seeing work being done at parity, if there's collaboration, if this is, traditional, like, oh, this happens to be happening in two places at once. Further than that, if you feel like there's an opportunity for not just tools, but standards, if we're not going to share tools, at least we can share standards, that kind of thing. What your thoughts are on that?
Well, I mean, we're with the government. Of course, we're repeating that multiple people are doing something similar. That's a given, and that's even true within NASA. It's that there's collaboration opportunities, definitely. We're not trying to, nor should we, compete with industry or with others. I was very much going after, the integration with NASA data and the data we need. Gemsec, one of the things I didn't mention is all those messages became an OGC standard. So I very strongly believe in, using those standards. And it's a publish subscribe type middleware, so it may not be applicable for all uses. And I know they don't support all devices, and that's one of the reasons we don't have it on collaboration on HoloLens. We have to use another thing, MQTT, to go the last mile type thing. I am always looking for collaboration. I love doing collaboration, whether it's with established missions or projects or whatever, or for R&D proposals. I am very open to that as well. I hope that answers your question.
Sure, thank you.
Yep. And we, as I guess you mentioned, we're demoing at 3 to 5, so you can come up and talk to me after it. Are there other questions? Yes, sir.
So going back to the beginning of your presentation, you were showing some demo regarding like moving some machinery and some equipment around the room. How would you go about, I guess, synchronizing the real world, like the room equivalent to what you built in 3D space to, I guess, sync up better, rather than just QR codes and like resetting position in like a certain spot you taped on the floor? How would you go about making solutions for different headsets that may not have certain sensors? Like I know the Quest Pro ripped out its depth sensor very late stages. Mm-hmm. How would you go about creating solutions for different kinds of headsets?
Well, some of that is we don't, quite honestly. We can't support all the headsets. We support the standards, and but I mean, the government, he was talking about the USB. We couldn't buy the Quest 2 because that was a USB computer that plugs in, or it's a computer that plugs into a USB port, and so NASA Security's definitely said never. So we are looking at partners, the universities to support. They've tested Quest 2. Now I'm trying to go back to your question. I'm sorry, I digressed a little bit.
I guess basically, how would you go about making solutions for, I guess, mixing the 3D model digital world to the actual physical world?
Yeah, so we are right now using Vuforia, for our area targets, our image targets, object targets. The image targets, obviously, is kind of, the QR codes or asset tags is a perfect one that we use for that. The image targets, within the limitations of Vuforia, they're useful. That is an area we struggle with. That computers look a lot the same, especially when we buy in bulk. Which one are we looking at? Unless we look at the asset tag, we can't even tell you, so we can't show you the telemetry that's on that computer without figuring that stuff out. That's active area where there's known deficiencies, and that we're trying to work on that.
Thank you.
Yep. If there's no other questions, I can give Ian more time. What's that?
The API that you gave to Space Force and they hardened it?
Yeah, the Gemsec.
Yeah,
They,
so-
they,
My question is,
sure.
after Space Force hardens it, do they then share it back with you how they hardened it and what they're using to harden
They
it?
paid NASA to harden it, so we already have it.
So you already have it? but
Yeah.
But they specifically won't share it with any other agency, right?
The Gemsec is open source as well. So,
And now it's hardening, its ability to be hardened to what Space Force requirements are now open source as well?
I'm sorry, repeat that, I couldn't hear that.
So the ability, what Space Force paid NASA to harden, that entire framework is available as open source as well, how they hardened it?
That's how I understand it, yes. A lot of it was making sure they used the applicable open, the standards for encryption, everything else. That Gemsec, as I mentioned, is an API and on top of whatever middleware, but then they added features within the Gemsec to encrypt whatever middleware is used and to protect your data and things like that. I don't know all of the features they added for the Air Force, but the Air Force paid at least a couple million to have the Gemsec project harden it. So that's an area I think we're definitely a differentiator, that we can be in these secure environments, and at least some of the DoD thinks it's useful in those environments.
Thank you.
Yep. Well, thank you very much.